Hello dear students, I am Surendra Sir, Master Teacher of Mathematics in Vedantu. In this session, I am discussing High Weightage Test 6, most incorrect questions done by students. This assignment is based on binomial theorem, general term and properties of binomial coefficient. So before I start solving the questions, before I start telling you the solutions of those incorrect questions, I will like to tell you few key ideas that you must know. The first thing is general term. General term of any binomial expansion x plus a power n is actually given by p of r plus 1 equal to ncr into x power n minus r into a power r. Please understand, if you are looking for second term, your r value will be 1, not 2. Here the formula is always in terms of r plus 1th term. If you try to write in terms of rth, there can be some confusion. That's why we have opted for tr plus 1 instead of tr. So please understand, whenever you are looking for second term, then r will be 1. If you are looking for fifth term, then r will be 4. So this is how this formula works. Okay. The second thing is the properties of binomial coefficients. So if you know the expression of NCR, I think this first result is one very simple direct. NCR is equal to n upon r into n minus 1 CR minus 1. So that is one you should remember. The second 2.2. Here NCR, sum of NCR plus NCR plus 1 is equal to n plus 1 CR plus 1. You can see I have highlighted these two numbers n, they are same. The number written above, you can say they are same here, but on the right hand side this number is 1 bigger than this. On the left hand side the numbers written below, they are at a difference of 1, then the number here will be copied from the larger number here. Okay, so this is how you can remember it. Dear students, you know this thing, summation of all binomial coefficients is 2 power n, so I have not written in this list, but there are results similar to this, that is r into ncr, okay, that is equal to n into 2 power n minus 1. Actually this comes from one of the differentiation, and you can feel it, it is like n into 2 power n minus 1. You know that differentiation of x power n. So similar to that you can think in your mind, although it is not the differentiation of 2 power n, but just to remember it you can think of that way. When r is multiplied here, it will be n into 2 power n minus 1. If with r there is term r minus 1, next r minus 1 and ncr, and you need to do the summation from r is equal to 0 to n, r is equal to 0 to n, then you can think of the same differentiation once more. So n was already there, n minus 1 will again come here, and this power will be reduced by 1, so it will be 2 power n minus 2. So this is how you can remember these two. I always suggest this r square into ncr by adding these two. Do not remember it, rather remember this by the symmetry of these results. Rather, I would like to tell you one more thing, that if r minus 1, r minus 2 was also there with NCR, here it will be n into n minus 1 into n minus 2, and power of 2 will be further decreased by 1. So this is how these results can be remembered, and whenever you need r square or r cube, you can by adding them always create this result. Okay. Now this Vendor-Mondi's identity, one very important thing, please understand what it is. Here I have written most general case. It is saying MC0 NCK plus MC1 NCK plus 1 and so on. Now you can see the difference here is of k, difference here is of k, difference here is of k. In fact, dear students, you can write MC0 also as MCM. You can also write this as MCM minus 1. You can write this as MCM minus n plus k. Now, if you change this MC0 to MCM or like this, you can see in this case your sum will become fixed, k plus m and k plus m. Okay, so actually whenever two binomial coefficients are multiplied and their difference are fixed, you can make their sum also fixed by changing one of the binomial coefficient that is multiplied in each term. Okay, now dear students, I have taken m and n two different numbers. Okay, this will go on till end. Till end, I mean to say that till you get meaningful terms. Meaningful term means, suppose you are getting, suppose n minus k, in some of the examples, suppose n minus k was bigger than m. Okay, in this case, or it becomes negative. In such case, you just consider those terms as 0, that's it. What I'm saying, starting with this MC0, the very first term, and take it to the last defined term, and if you in this formula find the last terms are not defined because this term is bigger and this term is smaller, or some of them becoming negative, you just ignore them, consider them as 0. This summation will be m plus n, the sum of these number above, m plus n, and sum of these two numbers here, so n plus m minus n plus k, so it will be m plus k. You can also write it as, using that formula, NCR is equal to NCn minus r, so m plus n Cn minus k. So this is also how you can write it. Okay, now the special cases of this identity, please see. Suppose if I write both m and n same, so it is NC0 into NCk plus NC1 into NCk plus 1 and so on. If you keep writing like this, plus this will be NC0 NCn. I think I have done something wrong, because 0 1 k plus 1, this would have been actually n minus k, not 0, n minus k. Yeah, so in this case this will become equal to 2n Cn plus k, that's it. So in this case the difference is of k, it will become 2n Cn plus k. There is one more special case of this, when k becomes 0. Actually that is the case when NC0 whole square plus NC1 whole square and so on plus NCn whole square is there, and you will be getting this to be equal to 2nCn. That is also one very important identity. Everyone must know this thing. There has been question on this. Okay, so now coming to the questions which are given in this session as most incorrect questions. So first one is NCR upon NC, r minus 1 is equal to k square minus 12, hold for n is equal to 2r, and we have to find the range of k. So dear students, in this case, yeah, you can write NCR as n factorial upon r factorial n minus r factorial, divided by, this will be n factorial upon r minus 1 factorial into n minus r plus 1 factorial, and that is equal to k square minus 12. Now you can see, yeah, this n factorial is directly cancelled. Okay, r minus 1 factorial will cancel r factorial r times, because r is bigger than r minus 1. Similarly, this n minus r plus 1, okay, so this n minus r will cancel this n minus r plus 1, because this number is bigger. So what we are getting here after this calculation, I think this will go in the numerator, n minus r plus 1 upon, this is just r, and this is equal to k square minus 12. Okay, and we are also given that n is equal to 2r. So 2r minus r, so r and r upon r will be 1. So 1 plus 1 upon r is equal to k square minus 12. Okay, so the value of k square is equal to 13 plus 1 upon r, and as we know, r will be starting with greater than or equal to 1 they have given, so the value of k square will be greater than or equal to 14. Sorry, yeah, how can I do this mistake? Yep. If r is greater than or equal to 1, so 1 upon r will be less than or equal to 1, so this will be less than 14, where 14 is possible. And if you keep increasing the value of r, okay, 1 upon 2, 1 upon 3, these numbers will be smaller. So 13 plus 1 upon r can go till 13 with open bracket. So k square will belong to 13 comma 14, where open bracket on 13, closed bracket on 14. So if you take the under root, I think root 13 to root 14 and minus root 14 to minus root 13. So answer of this should be B. Here I think open closed brackets are not proper. So answer for this should be B. Okay, now this question, the constant term in the expansion of. Now dear students, in this case, when we are looking for constant term, because there is 1 upon x term, if it was not 1 upon x term, then I would definitely gone with writing x is equal to 0. If you are given some polynomial and you're looking for its constant term, it is always when you get x, when you put x is equal to 0. But in this case it is not polynomial because 1 upon x term is coming, so we have to treat it separately. So what we will need, because constant term we are looking for, so here we will be looking for term of constant here which multiplied with 1, the term of x power minus 1 that multiplied with 2x, and then term of x power minus 2 that multiplied with this. So these three terms when multiplied with this will give you the constant term. Now first of all we will write the general term of 1 x plus 1 upon x power 10. I think the general term of this is 10 cr into x raised to the power 10 minus r into 1 upon x raised to the power I think r. So this complete thing becomes 10 cr into x raised to the power 10 minus 2r. Okay, so one thing that we have obtained here is the power of x is always in the form of 10 minus 2r, which is supposed to be even. Okay, so the constant term that we are looking for, now I can write it directly. This 1 when multiplied with constant, that means x power 0 term, and x power 0 term will come here when you take r is equal to 5, so that will be 10c5 here, then minus 2 x when this is multiplied with x power minus 1, which cannot be obtained here because this will always give you even values. So here it will be 0, 2 into 0, then plus 1 here into the coefficient of x power minus 2 that will come when you take r is equal to I think 6. So that will be 10c6. So that will be the answer, 10c5 minus plus 10c6. You can check the values. I think 10c5 I remember it is 252, and 10c6 is, you can calculate it. I think no one is supposed to remember them. I think it is 210 maybe. Okay, so the total thing will become 462. And also among the options you can check, this cannot be the answer, other values cannot be the answer, so this has to be the answer of this question. So simple question. Now coming to the next question, s is equal to summation k equal to 0 to n k n c k whole square. Now you can see it is something like k into ncr or r into ncr and that vendor Mondi's identities. This is a combination of these two. So how to deal with this? Now dear students, in this case you can do it in two ways. I will tell you two methods. The one method could be that you write this as summation k into nck into nck once again. Okay, now k into nck, I can write this as summation n outside n minus 1 into n minus 1 ck minus 1 into nck. Now n is constant, so I can take it out. K is equal to 0. You can start with 0 or you can start with 1. It's same thing, because for k equal to 0 it will be 0 anyways. So here we will be starting with k equal to 1, you can say. So n outside, so this is actually the general case which I wrote in the beginning. Okay, so k equal to 1 till it will go n. So I think this will be n into 2n minus 1 c. In this case what I told you, that can be written as n minus k also, and the sum of these two will be the answer. So 2n minus 1 cn will be the answer. You can write this n minus 1 ck minus 1 as n minus k. So summation here and summation here, if their sums are same, so using that identity in general we can write it will be n into 2n minus 1 cn. I think there is a problem in this question because these two options are matching, they are same. 2n minus 1 cn or 2n minus 1 cn minus 1, they are same thing, so both should be the answer. I think they have given c only. Okay, so that is one method. Okay, what could be the other method? Please understand, the other method could be that you can write this summation as 0 into nc0 square plus 1 into nc1 square and so on. The last two terms would be n minus 1 ncn minus 1 square plus n into ncn square. Okay, now you reverse the order of this entire thing, so that last term will come here, so it will be ncn square, and I can write ncn also as nc0. The second last term will be n minus 1 and I can write this as nc1 square and so on. The second term here will go to the second last position, and that will be nc n minus 1 square plus 0 into nc n square. Now if you add these two, it will be 2s is equal to n common, and that the general case, not general, sorry, special case, you can write it directly 2ncn, the sum of nc 0 square plus nc 1 square and so on, ncn square. So this will give you the answer, and this 2ncn you have to write it as 2n taken common, and then it will be 2n minus 1 cn. You can check, it comes out like this. Just let me check, because 2n will come there, 1 n factorial will remain, and 1 n factorial will become n minus 1 factorial. Yeah, so that's correct. So, and actually 1 upon n also will come. So n upon n will also come. So this will be overall 2 here. So 2 if you cancel, you will get same answer. S is equal to n into 2n minus 1 cn. So B or C, they both can be the answer. Okay. Now coming to the next question, the coefficient of x power 50 in the series 1 plus x whole power 100 plus x into 1 plus x power 99 plus x square into 1 plus x power 99 and so on. Now dear student, this question can be done in two ways. One method is that you apply formula of GP, because you can see it's a GP whose common ratio is x upon 1 plus x, and the total number of terms would be, I think this start with x power 0, and every time your power of x is increasing and it is going till x power 100, so total number of terms would be 101. So if I write the sum of 101 terms of a GP, its first term would be 1 plus x power 100, 1 minus r, that is x upon 1 plus x whole raised to the power 101, and whole divided by 1 minus x upon 1 plus x. Okay, so this is the formula of sum of 101 terms of a GP. First term this, common ratio this. Now if I take this as LCM, or rather I multiply by 1 plus x power 100 inside and one more 1 plus x, so that this will not be there, and you will be getting 1 plus x power 101 minus x power 101 into 1, not this thing, sorry, so like this, and divided by, it will become 1 plus x minus x. Actually this 1 plus x power 100 if multiplied will give you 1 plus x term here, but because 1 plus x term is there in the denominator also, so I will be multiplying by additionally 1 plus x here and 1 plus x here. So ultimately you will get this in the numerator and this in the denominator. So this is cancelled. So what we are getting this as 1 plus x power 101 minus x power 101. So if we are looking for coefficient of x power 50, that only can come from here, and if you write general term, I think 101 C 50 should be the answer. I hope they have not made the mistake. I think here also they have made the mistake, because these B and D will be same, 101 C 50 and 101 C 51, these two are same. Okay. Now coming to this question, oh sorry, I forgot that I need to tell you one more method for this question. Yeah, another method. Now another method for this question could be that coefficient of x power 50 for this, from this will be 100 C 50. From this it will be 99 C 50. Okay, not 50, 49, because one x is already there. So 99 C 49 from this, and x power 49 we will take from here, x from here, so this will make this to be x power 50. Similarly here it will be 98 C 48 and so on. I think this will terminate somewhere when it becomes 48 C 48, if I am not wrong. 48 C 48. Actually somewhere in between, as your powers will keep decreasing for this and increasing for x, so x power 50 will come there, and the sum of these two is always 50, so this will be x power 50 here. Okay, so x power 50. So here we will be getting constant term. Just 1 minute. I think I am missing something here. 1 minute. 100c 50, 99c 49, and so on. Okay. The mistake was that it should not have been 48c 48. It should be 50c0. It should be 50c0 because in this case we will be taking the constant term. So 50c0. Now in all of them you can see the difference is of 50, 50, 50, 50. Okay, let me write the first term first, that last term first actually, and I will write this 50c0 as 51c0. That is one very important trick of solving such questions. The term just before it would have been 51c1 because there is a difference of 50. So 51c1, and before that it would have been 52c2 and so on. And the last two term would be we can write 99c49 plus 100c50. Now these two if you add, I think you can use that identity NCR plus NCR plus 1. It will become N plus 1 CR plus 1. Now this again combined with 52C2 will give you 53C3. So if you keep doing like this, okay, you will get in the final thing as 101C50. Okay, that's it. So that's the same answer which we were getting otherwise also. So these are two methods for this question. I think the GP method is definitely better in this case, or it's your choice actually. Now coming to coefficient of this, coming to this question, we're asking coefficient of x power 2024 in the expansion. Okay, dear students, try to understand this 1 minus x plus x square and 1 plus x. If you combine them, you will be getting 1 plus x cube. Okay, these are the factors. Now, if it is having 4048 power, this is having 4047 power, I can write 4047 and then 1 plus x will remain from this because this is having 1 power higher than this. Okay, now we have to find the coefficient of x power 2024. Now dear students, in this all the terms would be of x raised to the power 3k form. That means power will be in the multiple of 3 because x cube is already there. So whatever power you raise to this x cube will give you 3k form. Now 2024, if you take the sum of the digits, it is I think 8, which is actually 3k plus 2. And you know the property, if sum of digits is 3k plus 2, then this number will also be 3k plus 2. Now all the powers of x being 3k when multiplied with 1 or x can give you the final terms either as x power 3k or as x power 3k plus 2, 3k plus 1, sorry, 3k plus 1, but you can never ever get 3k plus 2. So in this case, this term is not possible. So answer of this question should be C. Okay. Coming to this question, it says in the expansion of root 2 plus 1 upon root 5 power n, the ratio of fourth term from the beginning to the fourth term from the end is 1000, then n we have to find. I think fourth term from the beginning means 3 plus 1 we will be writing, and let me say 3 plus 1 L for last. Okay, so in this case here it will be NC3 and root 2 power n minus 3 and 1 upon root 5 power 3. Whereas to write it from the last, I think it will be NC n minus 3, root 2 will be having power 3 and 1 upon root 5 will be having power n minus 3. I think these two are same, so they will get cancelled. Okay, now the power of root 2 you can check, it will be n minus 6. Whereas root 5 also after simplification, because it will come up, it will also have same power n minus 6. So this is actually 10 power n minus 6 upon 2, which is equal to 1000, which is equal to 1000. So n minus 6 upon 2 is becoming equal to 3 because 1000 is 10 power 3. So the value of n will be equal to 6 plus 6, it is 12. Answer of this question is C. No other answer? Yes, C is the answer of this question. Now this question, the coefficient of rth term, r plus 1th term, r plus 2nd term in the expansion of 1 plus x power 14 are in AP. Okay. So dear students, if we are looking for rth term, so it will be written as T of r minus 1 plus 1. So the coefficient, because it is just 1 plus x power 14, so we can only choose the binomial coefficient. So the coefficient here would be 14cr minus 1. The second one would be 14cr and then 14cr plus 1, and they are in AP. And you know the property of AP, the sum of this plus this has to be equal to 2 times this. So 14cr minus 1 plus 14cr plus 1 will be equal to 2 times 14cr. Okay, after that it is simple calculation. You may choose to do it in numerous ways. One of the method is direct, that you divide by 14cr on both sides. Okay, so 14cr if you divide 14cr if you divide 14cr, I think this will just cancel it, and you will be getting in this case 14 factorial here and here will be cancelled, r factorial will come up and r minus 1 factorial will be cancelled, so only r will be there, and then I think it will be 15 minus r in the denominator of this thing, plus in this case I think r plus 1 come in the denominator after simplification, and this will be 14 minus r here. Yeah, 14 minus r here, and that is equal to 2. Now if you solve it, you will get a quadratic and then you will get the answer. Okay, so I think we have to take the LCM, nothing, no other option. You just take the LCM, so it will be r square plus r here plus 14 into 15 is I think 210, and then minus 29r minus r square, actually plus r square, and that will be equal to 2 into multiplication of these two, so it will be minus r square and 15r and minus r, so plus 14r and plus 15. So the final thing we are getting r square, 2r square, so 4r square that side, and the constant term would be 29 minus 28, and this 28 will cancel it. No, sorry, minus 28, sorry. So it will be 56 that side, 56r, and 210 minus 30, so 180. So that is equal to 0. Okay, so we can divide by 4. So we will be getting this quadratic to be r square minus 14r and plus 45 is equal to 0. So the quadratic will be having r minus 5 and r minus 9 is equal to 0. So either 5 or 9 will be the answer of this question. Yeah, I will tell you another method. Please listen carefully. My other method is bit simpler, and that simpler method is 14cr minus 1 plus 14cr plus 1 if you take, and that is equal to 2 times 14cr. Okay, let's do one thing. Add this term 2 times 14cr on both sides. And why I am doing this thing, I'll tell you the reason. If you do this here, in 14cr plus 14cr plus 1, this will become 4 times 14cr. Now you can apply that property I told you in the beginning. This will be 15cr and this will be 15cr plus 1, and that is equal to 4 into 14cr, 4 into 14cr. Now if you again apply that property I told you in the beginning, it will be 16cr plus 1, and that is equal to 4 into 14cr. Now open, it will be 16 factorial r plus 1 factorial, and that will be 15 minus r factorial, and on the right hand side it is 4 into 14 factorial upon r factorial into 14 minus r factorial. So this r factorial will cancel this r plus 1 times. This 14 minus r factorial will cancel this 15 minus r times. What you can see here is, that r plus 1 into 15 minus r is actually coming out to be this 14. Also we can cancel 16 factorial, 16 into 15 times. 4 will cancel 16 4 times. So only you will remain with 60 here. This is equal to 60. Now you can do some guesswork also, because r is supposed to be integer. So you can see if r is equal to 6, so this will be r is equal to 5 actually. So this will be 6 and this will be 10. So it is satisfying it. 9 also satisfying it. Also, if you do not want to do this, then just simple multiplication will also give you the same quadratic which we got here after some calculation. So this is the other method of this question. I hope you will like this method. So that's it for this session. Thank you so much. Bye everyone. Take care.